This is our last phylum of invertebrates, and it's the phylum Echinodermata. And now we're moving into animals called deuterostomes. If you remember during development, if the first opening becomes the anus and the second opening becomes the mouth, then they're deuterostomes. So the chordates, which include the vertebrates, which include humans, are deuterostomes as well. So really the animals, the invertebrate animals that are most closely related to humans are going to be the echinoderms, phylum Echinodermata, even though it doesn't really seem that way when you look at the characteristics. When you observe the characteristics, it doesn't seem like a sea star is more closely related to us than, say a grasshopper, but they are. So the echinoderms are invertebrates and they are deuterostomes. That means the second opening becomes the mouth. They include sea stars, sea urchins, sea cucumbers, and sand dollars. As adults, they do have radial symmetry, but they have bilateral symmetry as larvae. And they don't have an exoskeleton, they actually have an endoskeleton. And that endoskeleton is where they get their name, echinoderms, or meaning spiny skin. The endoskeleton is made of calcium-rich plates with spines, and that's where that name comes from, echinoderm, spiny skin. They have a central nerve ring that has branches, so that's a little different. And then they have the probably one of the most distinguishing characteristics that they have is their water vascular system, because they use it for locomotion or moving, they use it for feeding, and they use it for gas exchange and sensory reception. So we are going to dissect a sea star. So this is a good review for that. So if you look into a sea star from the top side, which is called the aboral side, that means not oral. Their mouth is on their underside. So if we go into a sea star from the top side, we'll see a structure called a sieve plate or a madreporite, which is like a little stone. And that little stone is porous. So water enters the madreporite first. That's how water gets into the water vascular system. But you would also see this structure. It just looks like a brown sac. I mean, it's like this very thin tissue, but it's just this brown sac. And it's the stomach. It's the sea star's stomach. And so here's what they do when they eat. They actually take that stomach and throw it up out through their mouth on the underside. The stomach will surround the clam, or whatever it's eating, and then enzymes will digest the animal. And once the animal is completely digested, it will pull that stomach back in through its mouth. So I think that's pretty cool. Then you have the water vascular system, and I'll try to explain that. So water enters through the sieve plate or madreporite, and then the water goes into a, it's called a, it's a canal. I'm trying to think what it's not the ring canal, but I can't remember the name. I'll make sure I know by lab time, but it's water goes into the madreporite, and then it enters a canal, a little canal right in this area. And then it fills up a ring canal. So there's a ring of kind of like just vessels, I guess you say, but in the shape of a ring. So the water enters the madreporite, and then there's I know what it's called. It's called the stone canal. I'm sorry. So water goes into the madreporite, the stone canal, the ring canal, and then there are radial canals that travel down the length of every one of these arms. So the radial canals the water enters the radial canals and then into the tube feet. So the tube feet, when they fill with water, they actually, the sea star can actually crawl along the ocean floor. It can walk along the ocean floor using those tube feet. And you can see they kind of look like that. Each arm has an eye spot on the tip of the arm. And here's some other echinoderms. This one is called a sea apple. There's also one called a sea cucumber. This is a sea urchin. You may have seen sea urchins before, like in a touch tank. So the water vascular system, here we go. All right, for the water vascular system, water enters through the madreporite or sieve plate and then through a series of canals. And the canals go in this order. It's stone canal, ring canal, radial canal. And then there's an ampulla that contracts and forces water into the tube feet. And those tube feet fill up with water, and the sea star is able to walk along the ocean floor. All right, so that is it for our last recording, and I just want to review with you the groups of animals and like how we've got them classified. Going back to our phylogenetic tree. Here we go. All right, so we start out with animals that don't have tissues, and that's going to be our sponges. And the sponges are from the phylum Porifera. Then we have two groups of animals that do have tissues, but they only have two tissue layers. They're called diploblastic, and that is our Ctenophora, phylum Ctenophora, or comb jellies, and our phylum Cnidaria, which includes jellyfish, the Portuguese man-of-war, sea anemones, hydra, corals. Okay. Then we have the animals in the group called the Lophotrochozoans. And the Lophotrochozoans, to me, are the hardest to remember. But the Lophotrochozoans are protostomes. That means the first opening that develops that forms in development is called the mouth, or becomes the mouth. There are 4 groups of Lophotrochozoans that we learned. We really didn't go into the Lophophorates because they're very ancient, and we don't have a lot of examples. I don't even know if we have any living Lophophorates. So we only learned 4 groups for the Lophotrochozoans. We learned the phylum Rotifera, the phylum Platyhelminthes, or flatworm, and that included the Planaria, which you see here, and the tapeworms, and the flukes. And we have all 3 of those in lab. And then we have the mollusk, or soft-bodied. Those include the class Gastropoda, or stomach-footed, which is our snails and slugs. The class Bivalvia, which is your clams and oysters. They have 2 shells. And then we have the class Cephalopoda, which is our octopus and squid. All right, then we have our phylum Annelida, which is our segmented worms. And we learned about the earthworm, the clam worm, which is a marine worm, and then leeches. So those are our 4 groups of animals that are in the Lophotrochozoans. That is annelids, mollusks, flatworms, and rotifers. Then we have 2 that are ecdysozoans, and that means they molt or shed. And that's going to be our roundworms, phylum Nematoda, and our arthropods, which is phylum Arthropoda. The arthropods include the insects, the crustaceans, which will be shrimp and barnacles and crabs and lobsters, the chelicerates, which includes spiders and horseshoe crabs and ticks and mites, scorpions, and let's see, crustaceans, I said, chelicerates, and insects. Oh, millipedes and centipedes. Remember, millipedes have 2 pairs of legs per body segment, and centipedes only have 1 pair. All right, then we have our deuterostomes, which that means that their second opening that forms in development becomes the mouth, and our phylum Echinodermata, which includes sea stars, sea urchins, sand dollars, sea cucumbers. So that's going to be phylum Echinodermata. Now our next phylum, which is phylum Chordata, is going to be in chapter 29. And most of those have a backbone and they're called vertebrates, although there are a few, 2 or 3 examples of animals that are in the phylum Chordata that don't actually have a backbone. So anyway, we're going to stop here for chapter 28. And when we cover chapter 29, we'll get the phylum Chordata. That'll be the last of our animals.